Here's a quick overview of a remote online lab we developed for a high school physics course. The device itself is a Geiger counter located at the University of Queensland in Australia. The lab starts with an interactive flash simulation that allows the students to see how the device behaves by moving it up and down and visualizing how the radioactive particles hit the Geiger counter. They can also get information and additional readings over here. For example, they could ask how's radioactivity measured, and they can get a reading on Geiger counters and how those measure radiation. Moving on, the student lab journal prompts the students for various questions and feedback. So here they need to write their research question. How does the intensity of radiation change as a function of distance? Next, I click design phase, and we're going to save the information to the server. Now the student needs to design their experiment. So I'll pick a short distance, say 30 millimeters to measure radiation at, and a distance that's further away, say 60 millimeters. And I'll measure for maybe 3 seconds each time. I'm not really sure if I'm a student. And I'll repeat it 2 times. Then the lab journal asked me, why did I want to choose these distances? And so I'll say, well, I wanted to try some close by and far away. And 3 seconds seemed like a good time to start with. I'm not really sure. So next I click investigate. My lab is then sent over to the device in Australia. I'm the number 1 in the queue. I've got about a minute left, and now I can switch over to a live webcam view of the device. Here's the Geiger counter on your left. There's a turntable that's going to spin the radioactive materials underneath. You can see the Geiger counter tube now moving up to my 30 millimeter distance that I typed in, taking the measurements, and then it's going to store all that data on our server for the students to then analyze later. Now you can see it's moving up to the 60 millimeter distance that I typed in. Again, it's going to collect the data. In the meantime, I could log off if I don't want to wait for it, or I can come back here and finish the prompt on my journal here. What is my prediction about what will happen? What do you think you'll see? And I'm going to type in, well, I think the intensity will go down the further away the Geiger counter is. In the meantime, the data is being sent back to the server. And if the student wanted to log back in, they would come back immediately to this screen here and pick up where they left off, so there's no need to wait. Once the data comes back, I'll be able to analyze it either by exporting it to Google Docs or Excel. So I can click here to export it. Or alternatively, I can use the built-in graphing tool that we have. So looking at my results, I can see that they do go down. But also they're a little bit different. So I'll write my initial observations are that the counts went down by about half, but each trial is different, so I'm not sure which number is right. So next I'll go ahead and fire up my analysis tool, do some graphs, insert those graphs in my lab journal, and then at the final question I'll explain that I think the relationship looks like a linear relationship with a negative slope, and I'll say, well, I probably want to run the lab again to see if the values I get keep changing. Finally, at the end of the lab, I can download a PDF, and then I can turn that into the teacher to complete my assignment.